Hi everyone, very good evening and welcome back to Geeks Who Geeks Practice. Today we'll be discussing another problem of the day, that is largest sum, subtree sum in a tree. So please give me a +1 in the chat if my voice is clearly audible to everyone, and then I'll share my screen so that we can start with the problem as well. So please give me a +1 in the chat if my voice is clearly audible to everyone, and then we'll start off with the problem as well. Okay, so let me look at the chat. You can hit the like button as well if you haven't already. Okay. Like, okay, great. So let's begin with the problem now. What does the problem say first of all? The problem says largest subtree sum in a rectangle. Okay. So basically, let us say that if we have any if we have any tree. So let's say if I'm building this tree up, let's say this is my tree. So this is a tree structure. Now, what is a subtree? Subtree is kind of a tree only, but inside this tree. So if I will consider this segment, so this can be considered as a subtree. Okay. If I will consider, let's say, this much part, so this will be considered as a subtree. If I will consider, let's say, this whole part, so this will also be a subtree. Okay. This part can also be a subtree. Individually, this node can also be considered as a subtree. Okay, this node can also be considered as a subtree. Let's say if this had some other nodes, so let's say this was like this, and then this would have been another subtree. So is it clear what is the definition of subtree? If this is clear, please give me a +1 in the chat, everyone, and then we'll continue with the problem. This is the definition of subtree. Basically, from a particular node, like starting from a particular node till the very end, you have to consider all the nodes. That is what we mean by the definition of subtree. This is what subtree means. Is it clear to everyone? Okay. Now, what can be done? There's one brute force way that we can solve this problem. Okay, there's one brute force way. Now, what is the brute force way in which we can solve this particular problem? What we can do here is, like, we can say that, can I say that if I am considering the subtree, so let's say if I am at this node, okay, let's say if I'm considering the subtree starting from this node, if I'm considering the subtree that is starting from this node, then starting from this node I can run a DFS or a BFS, anything. Like from this node I can run through all other nodes and I can take out the sum that will give me the subtree sum for this node. Okay, so let's name it as sum1. Okay, after that, let's say if I'm at this node, right? So starting from this node, like from this node I can say that, okay, I will take the subtree sum starting from this node, and every node that comes down I'll take the sum of that. Okay, let's say this sum, so let's name it as s2. Okay, another thing that I can do is, if I'm at this node, so I can say that starting from this node I'll take the sum of all the nodes lying down, so I will take the sum of all these nodes, right? So that will be sum 3. So basically what I can do is, like, if I'll have the sum like this, so I'll consider every node as the starting point. Okay, I'll consider every node as a particular starting point of a subtree, and out of that, like, from there I'll try to find the sum, and all the sums that I have overall I'll print the maximum out of them. Is it clear to everyone? This is the brute force manner in which I can do it. Like from one node, from one particular node I can iterate down, so that will take roughly order of n time, right, for one node. Now if I have n nodes, so that will take n into n time. Is this point clear to everyone? Please write clear in the chat, guys. Is everyone clear with this example? Is everyone clear with this basic part? Please quickly let me know. Is this point clear to everyone? Please write clear in the chat. That if I am at a particular node, so starting from a particular node, I will consider the subtree downwards. So basically from here, I'll take the sum of all the nodes, right? Then if I'm considering the subtree starting from this node, so from here I'll take the sum of all the nodes that are lying down there, right? So from one node, like, I have to do n traversal, right? So if there are n nodes, so n into n traversal. So that's nothing but order of n square, right? Which is very, very costly for us. Please give me a +1 if you agree with me. So can we do something better than this? Yes. What we can do is, something, some algorithm. Can I say that there are several algorithms for traversing a tree? Like there is pre-order traversal. Okay. There's something that is known as in-order traversal as well. And there's something known as post-order traversal as well. Okay. So whenever, like, you can mark this as a thumb rule, that whenever you have to solve inside a tree, you have to solve something in order of n time. Okay. Whenever you have to solve something in order of n time, like, what do I mean by that? So basically I'm saying that, let us say that if you have to find this subtree, like if you have to find the subtree sum of this guy. Okay, so basically this means that you have to find the subtree of like sum of this whole tree. So if I have to find the sum for this guy, right? So I can say that let us assume that all of the people towards the left, they are already calculated. The sum of the nodes towards the left is calculated, and the sum of the nodes towards the right side is already calculated. Okay, let's say I have a left result. Okay, let us say that I have a right result. Then the overall sum will be what? Adding this current guy. Okay, so can I say that I want the left to be already calculated and right to be already calculated, and then I'll add the root data to it? Is it clear to everyone? If I will take a sample, that okay, if we are having this particular kind of tree, so basically if I want the subtree, sum of the subtree that is at this particular node, so indirectly I can say that I want the left to be calculated. Okay, I want this left sum already calculated, and I also want the right sum to be already calculated. Then I can simply add the root data. Okay, so what kind of traversal it is? It is nothing but, like, first of all calculating the left, then calculating the right, and then calculating the root. Is it clear to everyone? Is this idea clear to everyone? Like whenever I am at a particular node, let's say if I'm at this particular node, let's say that if I remove the segment, and let us say that if I want to calculate the subtree of subtree sum at this node. Okay, so I'll say that okay, the left subtree sum is already calculated, and let's say the right subtree sum is already calculated. Then the subtree sum at this particular node will be nothing but left sum plus right sum plus the root. So left, first of all calculating the left, then calculating the right, and then calculating the root. Is it clear to everyone? Please tell me, guys. Is this part clear to everyone? If you are clear with this, please give me a +1 in the chat. Is it clear? Okay. Is this point clear to everyone? Okay. Right. So this is what you have to do. Basically, first of all, calculate. Okay, Gaurav Kumar says yes. So basically, first of all, you'll calculate the left, then you'll calculate the right, and then you'll calculate the root. Okay. So Tejas is also saying yes. Great. So this is what we have to do in this particular approach. So what will we do first? Let's take one of the examples from here. So let us say that we have this particular example, right? So if we have this particular example, so as I discussed that first of all the left will be calculated, okay, the left subtree sum, then the right subtree sum, then we will process it for the root node. Okay, this is what we are going to do. Now when we are going to do it like this, when we are going to do it this way, so this comes under the category of post order traversals. Okay, so whenever you have to solve in a tree, whenever you have to solve the results in order of n time, so you can think of this traversal, that is post order traversal. That is first of all calculate the left subtree, then calculate the right subtree, and then calculate the root. Okay, hi Naikaj. So what will I do here? Let's take this example test case that was given, the second test case that is there. So 1, then I'm having -2. Let's say if I'm having the node 1, okay, then I'm having -2, then I'm having 3 here, and then I'm having 4, 5. If I'm having 4 here, then I'm having 5 here, and then I'm having what, -6 here. Let's say if I'm having -6, and then I'm having a 2 here. So I think this is the tree that has been given to me. Okay, so let's say what will happen. So we will start from where? We'll start from the root node. Okay, so we'll go to this guy. Now when I'm at this guy, so first of all I'll call for the left. Okay, so is it null? Is this node null? No, it is not. So I'll call for the left. So we will go to the left node. Okay, then we go to this guy. Now when we go to -2, then again we will say that okay, can we go to the left? Yes, so let's go to the left. Now when I go to this guy, so initially I will mark the maximum as 0. Please write 0 in the chat. Initially I'll mark the maximum sum as 0. Is it clear to everyone? Please hit the like button, guys, if you are clear till this point. Initially I will do what? I will mark the maximum sum as 0. Okay, initially the maximum sum overall is marked as 0. Now what I've done is I go to this node. Okay, now for this node also I go to the left. Okay, so I go to the left because first of all my tendency will be that for a particular root node I'll first of all calculate the left and the right, and then for the root node I'll be calculating. So I'll be at this node. Okay, now when I go to its left, does it exist? No. Please write no in the chat. For this particular guy 4, does its left exist? No, its left is actually null. So when it is null, so I'll return 0 from here. Okay, so basically my left is equal to 0 here. Now after calculating the left, as I said, first of all calculate the left and then right, and then for the root node calculate the sum. So then what I will do is, after that, after getting the resultant from the left, I'll go to the right. So does the right exist? No. So in that case I'll return 0 from it because the right is null. So right will return 0. Now I'll calculate it for the root. So what will be calculated for the root? The root, like basically the sum of the subtree lying at this particular node will be what? The current node data plus the left plus the right, which is nothing but 4 plus 0 plus 0. Okay, so this much part is there. Now indirectly I can say that okay, the sum will be what? Like 4 only. Is it greater than the maximum so far? Yes. So please write 4 in the chat. I'll update this maximum with 4. So I'll say that okay, the maximum sum that I found so far is nothing but 4. Okay, this is what will happen. So now what will happen? Now since the sum till this point has been calculated as 4, so you'll simply return 4 from here. Okay. Now after that, for this node, you can see that its left call is already done. Now you will go to the right. Okay, you will call for the right guy. Now when you call for the right, so when you go to the left, when you go to the left, so does it exist? No. So it does not exist. So it will return 0. Right, it will return 0. So for this guy, its left is returning you a 0. Now when you go to the right, right is also null. So when you go up, it will return you a 0. Okay, so after this, what will happen? If I'll see, so what if this is the current node? So what is the sum? The sum is nothing but the current node plus the left plus the right. Okay, so this is going to be nothing but 5 here. So in that case, what will I return from it? Like before returning, I'll check that okay, this the sum of the subtree till this particular node is what? 5. So is it greater than the maximum? Yes. So I'll update my maximum. So the maximum will get updated to what? 5. Right, the maximum gets updated to 5. Now after the maximum gets updated to 5, so I'll return this particular result from it. So this gets returned. Now you can see that L is returning what? 4 and R is returning 5, and this particular node is what? This particular node is what? This particular node is having a value of nothing but -2. Okay, so what is the sum of the subtree at this particular node? That is this particular subtree. What is the sum of the subtree starting from -2? So I can say that it is nothing but the current node data plus the left result that is already calculated, that is 4, plus the right result, so that is 5. So this is nothing but what? I think it is plus 7. Okay, so the sum of this particular subtree is what? It is nothing but 7. Now if it is greater than the, is it greater than the maximum? Yes. So maximum is 5, but this sum is 7. So I'll update this to 7. Okay, if you are clear with this, Rishit and everyone, then you can write 7 in the chat. Is this point clear to everyone? I hope it is. Right. So this is the point here, that now the sum is 7. So current sum here is 7 and the maximum gets updated to 7 as well. So what will happen here? Now I can say that this particular, from here I am returning 7. Right. Why am I returning a 7 from here? Because I am simply returning 7, because till this point the current that I store, like the current sum was what? It was nothing but the current node data, right? This node's data plus the left result plus the right result. So that is going to be nothing but 7. Okay, so 7 is returned from it. After this, if you will see, so for this guy you also did this call. So when you do this call, so you will be at this node 3. Okay, now when you come to this node 3, then what will happen? So see, again when you come here, so you come to this node, then you go to its left. Now you are at this guy. Now you call for its left. Does it exist? No. So it will return you a 0. Now you call for its right also, because first of all you will calculate the left, then you will calculate the right, and then you will calculate the root node. Okay, so you will go up now. Okay, and this will return a 0, because when you call for the left it does not exist, so it will return you a 0. When you call for the right, it does not exist, so it returns a 0. So this is L is equal to 0, R is equal to 0. Now what will be the subtree sum at this particular node? So since its left is returning you a 0, okay, and right is also returning a 0, and the current node data is -6. So what will happen? The overall sum will be what? The sum will be nothing but -6 plus like current node data plus L plus R. So this is going to be nothing but -6 plus 0 plus 0, which is going to be nothing but -6, right? So in this particular case, what will happen? You can see from here, I'll simply return, I'll simply check. So current sum is -6. Is it greater than the maximum value? No, it is not. So I'll say that, okay, no worries. If it is not, then even then I'll return this value. So I'll return for this left, I'll return -6. Okay. Then after that, for this node, I'll go to the right. When I go to the right, so I'll go to this node. Now I'll go to its left. So does there exist a node? No. So that is why it will return 0. Okay. Then I'll go to its right. Does it exist? No. So it will return 0 as well. So for this node, the left returns 0, right returns 0. Okay. So what is the sum of this subtree? It will be nothing but the current node data. That is what? 2 plus left plus right, which is going to be nothing but 2 plus 0 plus 0. Is it clear to everyone till this point? I hope that this much point is clear, right? So you can see here that after this, what will happen? So again, I'll check, is this current sum 2 greater than the maximum? No, it's not. So I'll say that, okay, I don't have any issues. Now I will return this particular sum as well. So basically what will happen from here? I'll return 2 from it, right? I'll return 2 from it. Now the moment this happens, so you will see, like what you will see, like R is returning you a 2 and L is returning minus 6. Now what is the subtree, what is the sum of the subtree? Starting from 3. So the sum will be nothing but, when my left is already calculated, for this 3 the left is already calculated and right is already calculated. So the subtree sum at this node will be nothing but the current root data, that is 3 plus minus 6 and then a plus 2. Okay, so this is going to be what? This is going to be nothing but 3 and plus 2 5, then minus 6. So this is going to be minus 1. Is it greater than the maximum so far? Please write no in the chat. Is it greater, guys? No. If you are clear till this point, you can write, you can give, hit the like button if you haven't already. Is it greater than the maximum? No. Is minus 1 the current sum of this subtree? The current sum of this subtree, that is 3 minus 6 and 2. It is what? It is coming out to be minus 1, which is not greater. Okay, you can write no in the chat, Naikaj and Chandra and everyone. Okay, so basically it is not. So I'll say that, okay, no worries. Even in that case, now I'm going to do what? From this node, I'll return from here and I'll return minus 1, because this is the subtree size till this particular point. Okay, starting from this node 3, the subtree size starting from 3 of this whole subtree is nothing but minus 1. So that is what I'm returning here. All right, then what will happen after this? You will see that, okay, now what has happened? Now for this particular guy, okay, for this particular node, its left is returning what? Its left, like its left subtree is having a sum as 7. Okay, this is having the sum as 7, as I discussed. So this is having the sum as 7, so it is returning a 7, and its right subtree is having the sum as minus 1. For the node 1, like you can see, for the node 1, its left subtree is having the sum as what? 7. Okay, please write 7 in the chat. And its right subtree is having the sum as minus 1. So left is returning a 7 and right is returning a minus 1 value. Is it clear to everyone? Okay, so you can see here that left is returning 7 and right is returning what? Right is returning a minus 1. Now what is the sum of the subtree at this particular node, which is nothing but the root itself? So it is nothing but the root data plus the left subtree value plus the right subtree value. So it is going to be what? This is going to be nothing but 1 plus 7, and then R is minus 1. So this will be minus 1. So if you will see here, I hope that I have written it clearly. So if I'll see, so this is 9 and this is 7. Okay, and this is also 5. Yeah, minus 1. So seems to be fine, right? So again this will be what? 7. So the sum of this subtree, the sum of this overall subtree is what? If you will see here, the sum of this whole subtree is also coming out to be 7. Why is it coming out to be 7? So you can see that the left subtree sum is what? It's nothing but 7. The right subtree sum is minus 1, right? And this subtree sum is 1. So 7 minus 1 and plus 1. So that is going to be 7 itself, right? So is it greater than the maximum? No. So please write mx7 in the chat. So I can see that my maximum subtree sum that I have seen so far is 7 itself. Overall, it is 7 only, because you can see that subtree sum, this was 7 also, this was minus 1, and the whole subtree sum, including the root node, is also 7 only. So the maximum is nothing but 7. Please write 7 in the chat. Is it clear to everyone? Please write 7 in the chat. Is it clear? So what have I done? Basically, if you will see, I basically did a recursive call and I went down. Okay, I went down to the bottom most, right? Because first of all, I calculated the left, like I went left, 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 I went right. Okay, then eventually I kept on moving up. Okay, so basically I can say that I visited every node exactly once, right? You can see that I just came down, I just went down with the help of recursion, and then from there on I kept on building the result. Okay, from bottom to up, I kept on building the result. So please write BU in the chat. Okay, first of all, in the bottom, I kept on building the result and I kept on moving up. Is it clear to everyone? Please write BU in the chat if you're clear with this, and hit the like button as well if you haven't already. Is this point clear to everyone? I hope that this makes a lot of sense to everyone. Is it clear? Is it clear to everyone? Basically, what will I do? First of all, I'll call the recursion. So recursion will go to the left and the right. So basically, I'll go down, 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 and then one by one, the result will keep on building from top, bottom to top. Okay. So basically in this case what will happen, I'll simply go down. First of all, calculate the go down, hit the bottom rock, and then one by one keep on building the result, and then I'll go up. Okay, so in this case you can say that the time complexity in the worst case is going to be what? If suppose that a tree of this kind is given in the worst case, right? Let's say if you will assume that it's a skewed tree, so in that case I'll say that okay, I am going down and then I'm going up in this case. So you can say that it will be order of n in the worst case in terms of time complexity. Similarly, I can say that if this tree is given, so the space complexity will also be order of n, because in the worst case the recursive stack space extra that I'll get is again going to be order of n in the worst case when the tree is skewed in nature. Is it clear? The time complexity and the space complexity of my approach is clear. The time complexity is going to be order of n, because in the worst case, if the tree is skewed, then I'll be iterating through n nodes, right? And the space complexity is going to be order of n in the worst case if it is a skewed tree, because this is nothing but the recursive stack space if I'm using a post order traversal. Please write post in the chat, guys. Basically I am doing a post order traversal in this particular approach. So first of all, calculate the left subtree, then the right subtree sum, and then you calculate for the root. Is it clear to everyone? Please tell me if you're clear till this point, then I'll proceed further as well. I hope that everyone is clear till this point. Okay, so you can see that for this particular example, my answer is coming out to be 7, right? So this is the case here. Is it clear? All right. Now let's move to the coding part. You can write code in the chat if you think that we can move to the coding part. So I will take a maximum value, right? So let's say that I'm taking a global maximum. So let's name it as mx. Now what I will do here is I'll simply mark my maximum as nothing but int min. Okay. Let's say int min. So I'll mark it as very negative value, because why am I marking it as int min? Because I'm having some negative numbers inside this array now. So if I will, let's say, like if I have a tree, okay, let's say if I have a tree which is having all the nodes as negative, let's say this kind of a tree. So if I'll take my maximum as 0, so in the end maximum will still remain 0. So that is why I need to take it as negative infinity. Please write minus inf in the chat if you're clear till this point. Okay, that is why I'm taking it as negative infinity. That is nothing but int min. Is it clear? Because I might encounter some negative value, so that I cannot take the maximum value initially as 0. So I'll take the maximum initially as int min. Is it clear? You can write minus inf in the chat if you're clear till this point. Is everyone clear? And you can hit the like button as well if you have understood till this point. Is everyone clear? Okay. So now once I've done this, so what I'll do is I'll say that okay, I'll do a post order traversal. So let's name it as post order traversal, and in this I'll pass the root node of this particular tree. Okay, now in the end what will happen, the maximum will get updated, maximum sum, so I'll return the maximum sum in the end. Okay, this will happen after this post order traversal function has been written. So what will I do here? I'll have a int, and let's name the function again as post order. Okay, now what will I pass here? I'll pass the node star root. Okay, so basically I'll pass the root of this particular tree. Now what is the, like, if I'm writing this recursive function, okay, so what is the base case? First of all, if I'm writing this recursive function, that is post order traversal function, right? So there will be a base case in this. What is the base case here? That if you will observe that if I was traversing, right, you can tell me what is the base case here, that if I am having a particular tree with me, okay, let's say this is the tree. So if I'm going to the left or right, whatever I'm going, if I'm going to the left, right, wherever, like you can see here. So whenever I reach a particular route, like I need reach a particular node that is null if it is not existing, right? So in that case I'll return 0 now. Remember this, please write 0 in the chat. Whenever I reach a particular node, whenever my root node is equal to null, then what will I do? I'll simply return 0. Okay, so I'll simply return 0 from here. Otherwise, what will I do? Otherwise, what will I do? Can I say that if my, let's say, if my this node, like if you will see this particular tree here, okay, so we should return the value 0 in this case. Definitely, we should return 0. Okay, so if we are having this particular tree, now if you are having this particular tree, let's say, so if you are at this particular node, so first of all, you'll assume that okay, let's calculate the left for this guy. Okay, then let's calculate the right for this guy. Okay, so first of all, you'll do what, you will call the recursion for the left. Okay, you'll call the traversal for the left, and you'll call the traversal for the right as well. So what will you do here? You will say that okay, int l, or let's say left, or let's say left is equal to what, let's name it as post order. So I'll call this function and I'll pass the roots left node. Is it clear to everyone? I'll call this function. I'll pass the roots left node. Is it clear? If you're clear till this point, please hit the like button if you haven't already. Is it clear to everyone? Is it clear to everyone? Okay. And then in right will be equal to what? Right will be equal to post order, and I'll write this thing as uh, roots. Just give me a second. Okay. So post and order, this will be roots right. So I'll call for the left and the right. As I said, like what is the scenario in the post order reversal? Please write L R and then RO in the chat. Okay, what is the post order reversal? Left, right, and then the root. Okay, please write LRRO in the chat. What is the post order reversal? Post order reversal is, first of all, you calculate the left, then you calculate the right result, and then after that you'll calculate the result for the root. Okay, this is what we are going to do. So I can simply say here that, let's say, the current sum. Okay, the current sum will be what? The current sum will be nothing but the left sum plus the right sum, left subtree sum. So let's name it as left subtree, in fact. Okay, so left subtree, and let's name this as left subtree as well. So current sum will be what? Left subtree sum. Okay, plus the right subtree sum. Okay, then after that, plus the root data. So please write root data in the chat. Left subtree sum plus the right subtree sum plus the root data. Okay, and I'll say that, okay, maximum is equal to what? Maximum of the maximum that I've seen up till now, comma the current sum. Okay, so I'll always keep a track on the maximum as well. And from this particular current node, what will I return? If I'm, let's say, if my if this was the tree, let's say this was 5, let's say this was 6. Okay, so the left returned a 5, let's say the right was returning a 6. Okay, and my value was, let's say, 3. Okay, so what will I return overall? I'll return left data, left subtree sum plus the right subtree sum plus the root data. So what will I return in this case? I'll simply return nothing but 5 plus 6 plus 3, that is the current root data. So this is the current sum, right? This is the current sum. So what is the current sum? Current sum is nothing but, you can see here, 11 plus 3, 14. So overall I'll return 14 from here. So that is why overall I'll return what? I'll return the current sum. Please write current sum in the chat if you are clear till this point, that, okay, what I'm going to return in the end from this function is nothing but the current sum. Is it clear to everyone? You can tell me. I hope that this makes a lot of sense to everyone. Is it clear to everyone? Okay, so this is what I've tried to do here. I hope that it will work. If you're clear till this point, you can write clear in the chat. Okay, it works for the samples. You can see that it is working for this particular sample, right? The expected output was 28, and I'm also getting 28. So let's try and submit this code now. Okay. So it passes all the test cases, right? So you can see that the code that I had written, it passes all the 224 test cases that were there in this problem. And this was my second attempt for this problem. That is, I solved it yesterday night and today I'm solving it again. So this is the problem overall. Whenever you have, like, you have to keep this in mind, right? You have to remember this thing. You have to remember this idea that whenever inside a tree you have to calculate something in order of, like, if you are calculating in order of n square and you want to reduce that time complexity in a tree, then most of the times what might happen, you might already want the left result, you might already want the right result, and then you will calculate it for the current root. So whenever you want to reduce your complexity, okay, then you will use what? You will use post order traversal. So please write post in the chat. You will use post order traversal for those purposes, and I have seen this has worked for me. This should be marked as medium, not hard. Yes, I also agree that it could have been marked as a medium problem or easy problem, in fact. But basically, the idea is very important. Okay, so post order traversal is the thing that is important here. That is, first of all, calculate for the left subtree. Okay, calculate for the left subtree sum, then calculate it for the right subtree. Okay, and then eventually you will return what? Eventually you'll return for the root, that is nothing but the left subtree plus the right subtree data, left subtree sum plus the right subtree sum plus the root data. So that is what you will return in the end. So this is the idea, and this idea can be used for solving various hard problems of trees, and this idea will make it very easy. So please give me a +1 in the chat and hit the like button if you haven't already, guys. Is this clear to everyone? You can hit the like button if you haven't already. Okay, and give me a plus one in the chat real quick. I hope that it's pretty much clear. You can see that time complexity expected was order of n. So as I told, if it is kind of a skewed tree, then I will take order of n time to go down. And similarly, the auxiliary space that I'm taking in terms of recursion. So when the skewed tree is like this, okay, if the tree looks like this, so in such a case, the recursion stack will keep on building up till n. So that is why the space complexity of the recursive stack space that I'm taking is order of n as well. Okay, and this is the problem. So I tried to solve it as simply as possible. Again, we'll walk you through this code. Basically, you can see here initially, like I'm taking a global maximum. Okay, you can pass it in the function also if you want. So initially I'm marking my maximum as negative infinity. Okay, why am I marking it as negative infinity? I'm marking it as negative infinity basically because they are negative numbers as well. So I don't want to mark the maximum as 0. Okay, I will mark it as negative infinity, that is int minimum. Then I'll call this function. Okay, and this function will calculate the maximum subtree for me, and in the maximum sum subtree, and I'll return that particular value. Okay, so let's see what has been done here. Basically, if the root is equal to null, then you return 0. Otherwise, what you will do is you will first of all calculate the result for the left, then you will calculate the result for the right subtree. First of all, calculate the result for the left subtree, then calculate the result for the right subtree, and then calculate it for the root. So for the root, the current sum will be what? The left subtree sum plus the right subtree sum plus the root data. So that is what you will calculate. So that will be the current sum till this particular node. Okay, so in that case, you will always keep a track of the maximum, and from this node you will return the current sum, that is the sum of this particular subtree, current subtree. Okay, is it clear to everyone? Please give me a plus one once again and hit the like button if you haven't already, and then I can end the session as well. I hope that this problem is pretty much clear to everyone. Okay, is it clear? Now talking about today's problem of the day. So if I'll write GFD POD here, so you can give me a plus one in the chat, guys, real quick, and I hope that it's pretty much clear to everyone. Now this is another interesting problem, asteroid collision. It has been asked in a lot of companies as well. Like to be honest, this problem, today's POD, has been asked in Amazon. Okay, I think it has also been asked in Microsoft, I think, and most probably it has been asked in Adobe as well. Okay, so please make sure to solve today's problem of the day. Tomorrow midnight, Siddharth will be taking up this problem. So please make sure to solve it. I'll also solve it right after this live stream. Okay, so you can see that basically I'm also trying to practice regularly, if you will see here. So you can see my streak. I'm also trying to be a little bit regular these days. Okay, so please make sure to be regular. And for the one last time, please give me a plus one in the chat if you're clear with everything. Okay, is everything clear to you? I hope that the concept is clear. Basically, whenever you are given a tree, so make sure to remember this logic, that what you need to do is, whenever you have to calculate in a tree, whenever you have to calculate the result in such a way that you need order of n time. So at those places, you can use the post order traversal technique. I've tried it at various places and it has worked for me, because this is kind of a backtracking process, you can say, or it is basically when you are moving up, then when you are backtracking, then you ultimately calculate the result, and in this way you reach every node exactly once. So that is why it is order of n. So please make sure to remember this concept. Okay, and this was it for today's problem of the day. Thanks a lot, everyone, for joining in. And why are you returning the current sum, not the maximum? Okay, so I am returning the current sum basically because I want to return the current sum for a particular node. Now, like if you will, if I'll go down, I'm not sure where my diagram is. I think I lost it. Basically, if you will see, let's say if you have any node, okay, let's say if this was the node, let's say the maximum that you, let's say the sum of this particular subtree was, let's say 7. Okay, so the maximum, let's say, was 7. Okay, now when you're at this subtree, so let's say this is -1, this is -5, this is -6. So let's say, okay, let's say that, okay. So in this case, if this subtree, if I talk about, so what will I return from here? If its left is returning me a -5, okay, and its right is returning me a -6, and this value is -1, so this will be nothing but -1 and -5 and -6. So overall, what is the sum here? The sum of the subtree till this particular node is nothing but the current sum -1, the left result -5, and the right result -6. So it will be nothing but -12 overall, right? So what I'm going to do from here is I'm going to return a -12 from here, right? Because this will be the sum till this point. So that is why I'll return the current sum. Okay, I'll not return the maximum. Is it clear? Because the maximum, suppose till this node, like if the maximum was stored as this thing, let's have it as 3. Okay, so if the maximum was 7 already, but I will not return the maximum, I'll always return the current sum. Is it clear, Chandra the coder? I hope that this point is also clear to you. You always need to return the current sum, no, till a particular node, and not the maximum. You are already having a variable for calculating that. Okay, so this was the idea. If you are clear with this, Chandra, you can give me a +1. With that being said, thanks a lot for joining. Make sure to solve the problem of the day for today, that is asteroid collision. And make sure to subscribe the channel if you haven't already, if you're watching the recording or if you understood this problem properly. So make sure to comment understood after this video is over. And thank you. Good night. Take care, guys, and keep coding.